So today we are going to study about agents, and this is one of the most hot topic. And it is said that 2025 is going to be the year of agents, where different companies, different people, communities will be creating different type of agents. Okay, for the last 2 years, people were exploring what is RAG, what is advanced RAG, and now people have started creating agents. So it is said that 2025 is the year when most of the people will be busy creating different type of agents. So we'll study what are those agents and why they are so important. Okay, so in this session, we are going to see there is something called as the React pattern or the React agent. We will see what is the React agent is, how to build agents without using any framework. So if you talk about the frameworks, we have frameworks like LangGraph. LangGraph is the framework for building agents from LangChain. Similarly, from Microsoft, we have AutoGen and we have Crew AI agents framework. So there are a lot of frameworks in the market today and they are growing, right? Every day, every week, the different companies are adding more and more frameworks with the help of which you can create agents very quickly. But today, in order to understand what the agents are, what does they do under the hood, right? My aim is that you should know why do we use agents and what they actually do under the hood, behind the scenes, how they are working, and why do we need any framework like LangGraph or others to automate the things, right? What is the necessity of these frameworks? So if you build these agents without using any framework, then I think we will be able to understand, okay, these are the problems. If you don't use any framework, these are the challenges. And in order to overcome those challenges, we will use the frameworks. So in this session, we will use Python. We will create agents only by using Python. No framework will be used. And again, we will study what is React pattern, and what does it mean at the first place. Okay, so the question is what the agent is. So I will start from, somewhere like anyone has any idea what is agent as per your current knowledge? Guys, have you heard about agent? What do you know about it? Anyone? No one has any idea about agents.
It's automatic chart system.
Exactly. Autonomous. Autonomous is that word which is mostly associated with the agents.
Yeah.
Okay. So I will give you an example. Let's say I have to ask a question to the chat GPT. So what I will do, I will ask my question in the prompt and I will send it to the LLM. Then the LLM create a response and it will send me back some response. Okay. And then I will see, okay, then I will analyze my response and I will see, no, this is not exactly I'm looking for. Then I will again write another prompt and I will instruct my LLM to give me more accurate answer, or maybe whatever I'm looking for, right? I will add more instructions and I will send. Again, LLM will generate something, it will give you back. And so there is a to and fro conversation which is going on between a user and chat GPT or any large language model. So in the very simplest form, agent is something which can automate this loop. So there is a loop, right? You can see you ask a question, LLM respond back, you don't like, or maybe the answer is not complete. You're looking for something else. Then you send it back. It will give you response. You again send another instruction. So there is a loop, right? So before you finally get the final answer, you actually need to do a lot of to and fro, right? An agent is something which can automate this particular process. Okay, so this loop is can be automated in such a way that once I send my instructions, then the LLM should be and my agent should be able to think that, okay, in order to accomplish this task, this is what I need to do, and he will perform all those tasks one by one, and it will return the user the final answer. Okay, so this loop, which is which can be seen as a react pattern. So this is, I mean, there is one research paper which was released. So this pattern is called react. What is the react pattern? You have thought, you have action, and you have observation. All these three things when work in a loop, we call it a react pattern. So how it works? There is a thought basically. So let's say I want to make an omelette. Okay, so as a human being, what thing will come first to my mind? If I need to make omelette, okay, I need eggs. This is my thought process, right? In order to accomplish my final task, which is to make omelette, I need first of all eggs, right? Now I will again think, okay, how to get the eggs? Then I have couple of options. I can have, okay, in order to have the eggs, maybe I can go to the nearest shop and then I can buy, or maybe I can order online. So I have couple of options. So I have to think, right, what action I need to take. Should I go to the shop, or is it already there in my fridge? If it is there, if the eggs are already available at my home, that's fine. I will use them and I will make the omelette. But if they are not, then I need to see, okay, I need to take some action. Maybe I need to go to the market, or maybe I can order egg from my online grocery application, right? So this is how we as a human being think. Similarly, if our agent has to do some task, what it will do is, once you say, I will give you another example. Let's say we want it to calculate the sum of the total mass of all the planets. We have 8 planets, 8 or 9 planets, right? So if you need to calculate the sum of all the masses of all the planets, then I will give this question to my agent. So agent will see, okay, in order to accomplish this task, first of all, I need to find the mass of the Earth, and then find the mass of the Venus, and then find similar so and so. It will first calculate the mass, or find out the mass of different planets, and then it will see the user is looking for the sum of those masses, so it will add them up to give you the final answer. So in that respect, let's see what is the thought process. Thought is to get the mass of each and every planet. Okay, and then what we usually do is, when we write prompt for such agents, okay, we in the prompt itself we write how the agent has to behave. And we also say that, see agent or large language model, we have these many tools with you. So you make decision, you take decisions which tool is required at what time. So we will say we need to find out the mass of sum of mass of all the planets. It will say, okay, I have these tools. What are these tools? Like calculate mass. Let's say there is a function called calculate mass of a planet. So I will call that action. I will give the input parameter as maybe Earth. And the next, let's do step by step. I will say calculate or use this action. So this is what the action is. First of all, let me use, first of all, I will do a thought process, how to accomplish my task. And then in order to do the first step, I will use what actions are available with me as an agent. Okay, I will see I have 4 or 5 actions, let's say, which we have defined in the prompt. Then it will say, okay, use this action to get the mass of the Earth. All right. So I will select that action and I will execute that action. Once that calculate mass of planet function is called, it will return me some output. It will give me the mass of the Earth, right? So that is my observation. My output is my observation. Now that with that observation will again go to my LLM. It will think, okay, now since I have the mass of the Earth, let's calculate the mass of the Venus planet. So this loop will go and go and go in the loop until it get the mass of all the planets. Now it will see, okay, since I have the mass of all the planets, the user is looking for sum. So I need to call some mathematical function. So do I have a function which can add? Okay, I can see there is an action which can do addition. So I will call that addition action, and then I will send the mass of all those planets as an argument, and it will again, that action, that tool will be executed, and the result will be shown, and it will be given back to the LLM, and LLM will see, okay, now I have got the total mass. Do I need to go further in the loops? It will say, no, I don't need, because I have achieved my final goal. So it will say to the user, see, the sum of masses of all the planets is this much. Okay, so this is how this React pattern works. You have thought process. You, based on your thought process, you choose an action, you execute that action, and then finally you get the output from that action. That output is sent back to the LLM, and then it will see whether the goal is accomplished or not. If it is accomplished, it will exit from the loop. It will send the final answer to the user. Okay, so this is what the React pattern is, and we will use exactly this pattern to build our first agent. Okay, in order to explain you further, let's see. This is our system prompt. We need to design our system prompt. As I said, your behavior of your agent and LLM will be dependent on your system prompt. So we have to guide how it have to behave. So we will, in the system prompt, we will be writing, you work in a cycle or in a loop, basically. And the loop is thought, action, and observation. Thought, action, and observation. And at the end, you will get your final answer. Here are your available actions. So what action it can take, that also we will be defining in our system prompt. Calculate mass of the planet, or maybe add two numbers, or things like that. And now the answer, now having said all these things, now answer this question. So the user will be asking this question, and this prompt will be used. So how it will work, let me explain you again with this more detailed diagram. So we will have this system prompt, and when the user asks what is the total mass of Earth, so this time it is only asking one question, the total mass of Earth. So having said, we have this system prompt, we have this user question. Agent will say, okay, now I have to go to the large language model with this prompt. Your LLM will say, okay, my thought is that I need to find out the mass of the Earth. Now, what action I need to take? Okay, it will see these are the available actions. It will choose search underscore Wikipedia. This is, let's say, the action. So it will choose, okay, this action is useful for getting the mass. It will send the response back. Now we have to calculate, we have to use this action, execute this action. This is a tool. This tool, we will give the parameter as Earth. It will give the mass of the Earth 5.92 10 to the power 24 kg. And then once it is returned, again, it will see, okay, this is my final answer. Is it? Yes, this is. So it will exit the loop and it will send the answer back. Had the question being total sum of all the planets, it will go in the loop for a couple of times before reaching to the final answer. So this is how, basically, this is an intuition of how an agent works. And this is React pattern, reasoning and action. It reason behind, basically it thinks before executing. So that loop where, user was asking multiple questions has been automated. Now LLM itself will decide whether the output which it has got from the tools, is it sufficient, or it has to, maybe it has to call another function or another action, like that it goes on before the final answer. Okay, was it helpful, guys?
Yes.
So with this background, let's try how we can build our first agent. Okay, let me see if I have covered everything. All right. Yes, I think I have covered pretty much everything. So let's use Grok to build that particular. So I will go to Google Colab. Just a second. First thing we need to do is what? New notebook. All right. So our aim is to build a agent using Python and using Grok model. Okay. So first is like import OS, and then let's also pip install Grok. So we are not using any framework like LangChain or LangGraph or anything like that. We will use pure Python. So I'm installing my Grok library. Pip install Grok, invalid syntax. Pip install Grok is invalid. Is it GROQ or K? Let me check. Okay. This is being done, right? Now, what I need to do is need to set this os.environ, my Grok API key. Equals to, I already have in the keys, so I will take from here. I have set my key. Now we will write the code for my agent, or let's see. Let me take you to Grok. So far, whatever inference we did with this Grok, that was using LangChain. So now, in order to use it directly, this API key we have already set. We have installed the Grok, and this is our code. Okay. So import OS is being done already. So this is client. This I can remove because I have already set my keys. So client equal to Grok, and this is my completion. This is the list of messages. Role is user, explain the importance of language. This is the model I'm using. Llama 3.3, 70 billion parameters, and I'm printing. Okay, so this is how I can invoke my Grok model. Okay, so it says for the language models are crucial, blah, blah, blah. Okay, so that was just to show how we can invoke our Grok model without using LangChain by directly using Grok APIs. So we installed first the Grok APIs, pip install Grok, and then we set our keys, Grok keys, and then this piece of code will help you to inference the model. So far, so good. Next step is basically creating that agent. Okay, so we will create the class agent. Okay. So when we create this class, let me copy paste the code directly. So what we are doing is we are defining our class agent, and within that class, we have this init method, we have this call method, and we have this execute method. So let's have a look how this is working. What is the meaning of this code? So initialization is this method will be called when we initialize our class agent. Okay, and it will have this parameter client, and it will have the system parameter, whatever system prompt which I shown you on this deck, right? This system prompt, this will be, this is the system variable which will have this particular prompt, and we are setting this client. Which client we are going to use? We are going to use Grok client. Okay, and then I'm setting my system message and my client, and this is my messages array. What I'm doing is, in my messages, if the while instantiating this agent, if I'm sending my system prompt, then I'm appending that to my list, messages list. Role is system and the content is the system. Is that fine? This system variable. Is it clear, guys? So this is not the way we usually work in the industry, but this is the way to understand, to give you the basic structure or the code which is running behind. Once you understand this one, you can relate very easily any framework, how it is working basically. Okay, so I have defined one class called agent. I have defined this init method, which will be called when you first instantiate this class. And there is another method which is called call. So this call will be called when you when you instantiate this class, you will say like my planet expert equal to agent. And then once you call that object, planet object dot something, that time this call method is invoked. You will see that. Okay, so this is a call where I'm sending the parameter as a message. This is the message which the user will basically ask any question. What is the mass of my earth, mass of the earth? Okay, so this question, if it is not null, it will be appended to my messages list, which I have already created. And then this list is now having two messages. One is the system message, other is my user message. Okay, what is the mass of the earth? And what it will do is, then it will call another function which is execute, this one, which will basically send a request, which will do what? It will do the completion. Okay, whatever client we sent, it will use that client to do the completion. It will send all those messages. It will tell the name of the model and it will give me the answer. Okay, it will send these two questions in the messages, the system message and your user message, and then it will do the completion. Once the result is there from the model, it will append that result also in this particular message list. समझ में आ रहा है सबको या ऊपर से जा रहा है?
No, we are able to follow. I'm able to follow.
Good, good. Okay, so we are creating a class called agent, and I have defined three methods. One is, these two are the standard methods, init method and the call method. And then I have also written one method called execute. So my system message will be appended into my messages list, and then my user message, when he will ask the question, will be appended to my messages list, and both the messages will be sent to my model to get the completions. Once the response is received, it is also being appended into my messages list. This is all we are doing. Okay, now what we will do is, we will call this particular class. Okay, before that, we need to define our system prompt, right? So the system prompt is very important because this is having all the details on how it has to work in the loop. So this is my system prompt, which is saying you run in a loop of thought, action, pause, and observation. Okay, this is my cycle, right? This is my loop basically. And I'm giving instructions to my large language model saying that you are running in a loop. At the end of loop, you output an answer. Use thought to describe your thoughts about the question. We are explicitly giving instructions to the LLM that when I say thought, or when I say you are working in a loop, thought means whenever user is asking a question like what is the mass of this planet Earth, you have to give it a thought. Okay, you have to give a thought to the question which has been asked. With the action, use action to run one of the actions available to you. Okay, which actions are available? They are described here in the prompt itself. So we are saying thought, action, and observation will be the result of those actions. Okay, and we also need to give explicitly what are those actions available, what are those different tools. So I say there is a action called calculate, and this is the way you can use this calculate action calculate, and then you have to 4 into 7 by 3, simple mathematics. And you also need to describe your action basically. So it says runs a calculation and returns the number. Uses Python, so be sure to use floating points syntax if necessary. This type of lines are very, very important, which basically helps your LLM to understand what this function, how this action can be used basically. So we have to mind, we have to be very cautious while describing our different actions. For example, this is get planet Mars. This is name of my second action. And I say this is the example to call it. How I can call it? Get planet Mars and Earth as an argument. And what it will do, this action will basically return weight of the planet in kg. Okay? And after telling all these details that you are running in a loop, you have to behave in a React pattern, you have to do the thought, action, pause, and observation. These are the list of tools which are available to you. So you have to use these tools if required. And I will also give an example session. This is basically a few short examples in my prompt. For example, if the question is like, what is mass of the Earth times 2? You have to give a thought like, I need to find the mass of the Earth. Action is get planet mass, and I will pass the Earth, and I will pause. You will be called again with this observation. Once that action will be called, you will get some observation or some output from the action. Then you will be called again with this observation, like the mass of the Earth. Thought, I need to multiply this by 2 because my initial prompt was what is the mass of Earth times 2. Okay. So then once you get the mass of the Earth, you have to think what extra I need to do. Then your thought should be like, I need to multiply this by 2. And then you have to use the action calculate. You have to pass the mass of the Earth, multiply by 2. And then you will be called again with this observation, the result which we get after multiplying. And then if you have the answer, output it as the answer. Answer will be like the answer of the Earth times 2 is this much. Now it's your turn. Is it fine? This is how we are instructing large language model how it needs to behave. This is very important. Okay.
What is that password indicates here?
Which pass?
Like we are using that pass, right? The PAUSC.
Pause.
After everything,
Okay.
pause.
I will explain you. Okay. In some time, how it is important. Okay. I will explain. So thought, action, pause, and observation. What next? Next, I have to define those actions, right? So I will simply copy those actions. I will just put it here. So I have said that you have access to these 2 actions, but I need to define those actions, right? Those actions can be anything. They may be like they are calling some external third-party APIs. So for the time being, this calculate, this is just doing this operation. This is using the eval function, and it will do the multiplication or addition, whatever you want to do. The other function, other action is get planet mass, where we will pass the planet and it will check whether it's an Earth or whatever. It will return the mass of the respective planet. Okay, so I have defined these 2 my actions. Okay, now what next? Let's make now everything is ready. Now let's say I call it my agent as planet expert. Okay, so this is a planet expert. So what I have done is I have created instantiated my agent class. When I instantiate init method, what I need to pass? I need to pass my client and my system prompt. So that's what I have done. In the system, I have given system prompt. The client is my client. Okay, system prompt is what? Which I have just defined here. This is my system prompt, and my client, you already know, is my Grok model. Okay, so I provided these two values and I have instantiated my class. So when you call this method, when you call this init method, what will happen? It will just create all these things. It will set self.client as a client, says self.system as a system, and it will append those your system message into this messages. Let's see whether it is there or not. What I can do, I can say planet_expert. Let's tap into messages. So what you can see, this messages list has now the system message, right? The message which we defined, right? So it has now been appended to my messages list. Clear, guys? Nothing else. This is the only one message which is there in the messages list. Now this instance is ready. So what I can do is I can use my agent to call it. Okay. So when I call it like that, I'm actually doing what? I'm calling that call function. Okay. So my question is like, what is mass of the earth times 10, let's say? This is my question. This is my result. So when I do like that, what will happen? This question is my user question, and this will call this method. Okay. So when I do it by parenthesis and with my questions, then this particular method will be invoked. What it will do? It will see if it is not empty, it will append this message and it will call the execute method. Okay. So let me do that. Okay. Let's see what is there in the result.
Here we don't need to mention that the call function name, the method name.
No, it will be done automatically.
Oh,
Okay. So they are actually standard methods and functions. Okay. So whenever you are creating the first instance like this one, it will agent. It's like you are instantiating your class, then your init method is called. But once you have object of a class, and if you are giving it a question, then your call method will be called.
Oh, automatically.
Automatically. Okay.
Okay.
So now this question along with my system prompt was sent to where? I call this call method, right? What it called this call will do? I have asked this question, which will come in my message. I will append to the messages list. So now this messages has my system message and my user message, and it will call the execute function, this one. Execute function will basically take the messages and it will invoke my LLM. So what is the response from my LLM? Is the thought. We asked it that you are working in a loop. So it has generated this thought, this one. This thought basically. Is it fine? Here we send the prompt, and what it has done is it has created this thought process. So the thought process of the LLM is I need to find the mass of the earth. Now if I tap into my messages again, how many messages you will find there? Anyone?
2.
Only 2? Because I'm also appending my response.
Okay.
So there will be
3.
3. So my system message, the long prompt, my second user message, what is the mass of the earth? And my LLM is saying, this is my thought process. I need to find the mass of the earth. Okay. What next? This is my thought. I need to find the mass of the earth. Now in the message list, I have 3 messages. The result which is being produced by LLM. Now this list of 3 messages, I again need to give it to the LLM so that based on this thought, it can generate some action. Getting? It will do step by step, as we said. So what I will do, I will invoke this particular method again, but this time without any question, because the question is already been answered, right? What we want is we want to invoke the LLM again with its own answer thought. Okay. So when I do that, so it will generate the action. Earlier, there was an thought process. When I send all those 3 messages to LLM again, now it has generated the action that now I need to call get planet mass and pause. Is it fine? This pause I will explain you in some time. अभी तक ठीक है? Now it has LLM has generated this action that this is my thought process and this is the action I need to take. We gave it 2 actions and it is now able to tell me by its reasoning, by its own ability that I need to call this action, which is get planet mass. Make sense? But since right now the LLM cannot execute this function, what I will do is I will execute this manually. So what I will do, I will call this function. This is my Python function, right? This action is nothing but a Python function which I have written. So I will call this function with the parameter it has given as earth. So I will give earth, and what it will be, guys, the output is called what? The output is called observation. Okay, my output is called, when I execute action, the output is called observation output. So I will store it in my observation. Let's see. Okay, if I print, so now I have the mass of my earth. Okay, but this action was done manually by me. Okay, this was done by me externally. So what I need to do is I need to pass this observation to my LLM. Okay, so this is as good as a third party action. If I need to call any external API, any weather API service or some credit card service, whatever service I want to call, I can call that service, but then the output should be given to the LLM to judge whether it has to do some more processing or not, right? We are not going to the user to decide what to do now. We are going to the large language model. This is what an agent does. It automates that loop. So once we execute this function, we will give the observation to the user itself. So I need to design new prompt. New prompt is like, let me copy. Okay, and before that, if you want to see the list of messages, that has no impact on message, right? Because we invoked this externally. Okay. Now what I'm doing is I'm creating another prompt which will say this is the observation. This was the thought, that was the action. We executed that action, and now we are sending the result, the observation, back to my LLM. So I need to create one prompt, right? And with that prompt, I will be invoking my agent again. So planet expert is what the name is. So I will give this new prompt and let's see what it has. When I display result, thought, I need to multiply this by 10. अभी समझ में आ रहा है सबको? So when I send my mass by mass of the planet back to the LLM, it is now able to create another thought. That means it has to do one more loop. So now its thought is, now since I have the mass of the earth, I need to multiply it with 10 to get the final answer. So this is its thought. Let me see the messages. In the messages, you will see my system message and then my user message, the question from the user, then the thought process by the LLM. There is one empty message, and then this is the action which we need to take. We executed this action and we sent our observation, the result of executing this method back to the LLM saying this is observation. Now it says, now I think that I need to multiply this by 10 to reach to the final answer. Okay, so this is my second loop. What I will do, I will again, this is my thought process. Now, what I will do is I will send this thought again to my LLM. This is my result. Now it says calculate this into this. This is my action, right? I need to multiply this, but this time I need to invoke my calculate. This will be my second observation. So I will invoke this method calculate, and these are my parameters. Need to put codes or what? Okay. So if I execute that observation, one must be a string. Let me put the string. If I go back to calculate, where is my method? It takes as a string. My observation is done. Let's see the answer. This is my answer. So you can see the earlier the weight was 10 to the power 24. Now it has become 10 to the power 25 because it has multiplied it by 10. Okay. Now with this observation, what we need to do? Anyone please? भेजना पड़ेगा उसको, right? LLM को बताना पड़ेगा ना कि हमने we have executed this action and this is the result. So and then we have to run it again. Call this one again. I have created my new prompt. I will call my LLM again with the observation. I will do it like that. Thought. I have the answer now. The answer is the mass of the earth is times itna. Let me print it. Thought, I have the answer now. What is my final answer? The mass of the earth times 10 is itna. Is it making sense, guys? समझ में आया हमने क्या किया अभी? नहीं आया?
So every time we are passing like observation
Yes.
as the
Because
input,
because we are
like a loop.
exactly in order to complete that loop, we are doing it manually. So what these frameworks will do, that is just to show you that by using this framework, we can entirely automate the whole cycle. Okay. Otherwise, what we need to do is we need to create the prompt and we need to get the action, and then we are executing the action, and then we are sending the result back to the LLM to decide the next step. And it will decide, okay, now I need to call another action, which is calculate. Then it will also send the parameters. Then I will take that action and parameter execute. So there is manual intervention as well, right?
Maintenance efficiency.
Exactly. So that's why we will look into frameworks in the next class where we can automate all these things. These LangGraphs and other platforms, they provide us those APIs where we can build these workflows very efficiently. ठीक है? So this is without using any framework, we are just using Python. So this is how you can build an agent. Our first agent is ready, which can think of itself, it can do reasoning, it can decide what action to take. It's just that we are doing that action instead of LLM doing that action. Okay. So now what we will do, we will try to automate this in Python itself. Okay, how we can automate this? Anyone? In Python? Okay, let's look into the messages one more time. What are our final messages? Okay. Where is that message? This one. Let me re-execute it here itself. So you can see this is our initial system prompt. This is my question. This is the thought process. This is my action. Again observation. Again thought process. Again action. The final observation, and then the final answer. Okay. So now what we can do is, if in Python, if somehow we can if we can analyze this action, right now we are doing it manually. We are looking, okay, LLM is saying to execute this action. But if by coding, if I can read that the output from my LLM is like the name of an action, and then there is a pause, then what I can, this pause basically tells LLM that now it has to wait for another operation before proceeding. Okay, so
Okay, but
that's
we need like still one more loop or something. We like we
not
did not
the
finalize the answer or
correct.
final answer. So pause.
So
Okay.
when it decides that there is an action, appropriate action which can be invoked, then we have said in explicitly in the prompt that you need to pause, because we are going to execute this manually, right? So instead of proceeding further, you have to wait for some response. So that's why after this pause, we are manually calling this function. The output we are giving to the LLM to proceed further. Okay, so it will help the LLM to understand that it has to wait for something, wait for another response before going ahead. Okay, that's why we used pause. Also, this pause and this action will help us to interpret this output from the LLM. So when we are trying to automate, what I will simply do is I will check the output from my LLM. If that output is having action word and is also having the pause word, that means it was able to find some action, some suitable action. So I can parse this string, right? I can use some regex, regular expression. I will use some regex to find the name of the action and its argument. Then what I can do is I can take these words and I can call this function, right? In the coding itself, in the code itself. समझ में आ रहा है? I mean, what I'm trying to say. I will parse this string. I will find out which method or which action I need to call. Once I know the action, I can simply use that one, that action name, and I will pass the argument, and it will automatically execute that action. And whatever the result is, we will pass it to the LLM instead of.
So we will continue the loop until we find action and pause.
Exactly.
Like that. Okay.
And this is the standard syntax, right? With respect to action and pause.
Yeah, I mean, this is just one way.
Okay.
Okay. So how we will automate? Let me pull that collab file.
So Surendra, here the prompt, right? The system prompt, the template.
Mm-hmm.
So is this the standard template that works with all the models?
Yeah. I mean, it's the template which you can take as an inspiration and you can build your own prompts.
Okay.
Okay. Okay. So what we will do is we will try to automate this. We'll create another collab. We'll do same thing. We will install Grok. Just give me a second, guys. डोर बंद करो बेटा. So, okay, we have set the environment variable. Same piece of code of Grok. Import statement is missing. Same class and same prompt. I'm just creating another collab file with the almost same content. Okay. Okay. So this is so far so good. The same thing, Grok, OS, the client for the Grok, the agent class, the system prompt, everything is same. And this is my call. Now, in order to automate that thing, what I can do is I can write some Python code, which is like this. So what I'm doing is I have defined another function, which is like agent loop. And I have defined, okay, you can go maximum to 10 iterations. Okay. It should not be like that. Maybe if it is stuck somewhere and it is not able to find the suitable action or something, it will indefinitely go in the loop, right? So I want to exit from the loop once the iterations are like 10. And this is my query, my question from the user. And I will again pass my client and my system prompt to my agent. And then I have defined this tools list. It has two tools, calculate and get connect mask, right? Exactly same two tools. So I have defined it in a list. This is my new prompt. Whatever query the user will ask, it will go into the next prompt. And this is my counter I equal to 0, while I is less than the maximum iterations like 10. What it will do, I have just printed it once, and then it will pass my question to the agent. Whatever result is fetched from, what I am doing is I'm checking if pause is there in the result. Okay, so what kind of result I was having earlier? If I look at this result, this is thought, this is my action, right? From here, instead of invoking this method manually, I'm checking if this is the response from my LLM, then what I need to do is, so you can see the response, right? It has the action, it has the pause. So I'm doing exactly that. I'm checking if pause is there in the result, which is coming out from my agent. And if an action is also there in the result, what I'm doing is I'm using this regular expression RE. Okay, so this is another library. I'm importing regular expression to get the exact name of my action and my tool. Action and my arguments basically. Okay. Let me do one thing in order to explain you how it is working. Let me show you how does it work. Okay, so let's say I take this thing. This was the result, right? Copy, create another line. We'll say my result is equal to this thing. Okay, I'm just trying to show you how this regular expression will work. Okay, so if this is the content in my result variable, and if I use this regular expression, how the action will look like. That's what I'm trying to show you. Okay, let me.
RE won't be there.
Yeah, I think I need to import RE. Okay, so okay, so this is how I will get my output. So this regular expression will parse this string, and it will get me the value of my planet, the name of the action, and the argument which I need to pass. I hope this is clear now. So now, since I have the name of the action which I need to call and the arguments which I need to pass, I will again check if that tool or action is there in my tools list or not. So this list I created, right? It has two tools, calculate and this. And if it is there, I will simply use this eval function. This eval will do what? It basically execute whatever you pass inside this eval function, it will execute that. Okay, so what it will do? It will have the name of the action and the argument. We have passed both the things. It will execute that function, which we did manually, and the result will be stored in the result tool. And the next prompt, we created observation as the output. So this is how it will frame my next prompt. And then there are a couple of conditions. If it is not found, I will say observation is tool not found, so that this observation can be sent to my LLM saying that the tool which you suggested is actually not there. Okay, so that it can correct if it is wrong. And then I'm printing. Okay, so let me execute all these things. This I don't need. Okay, so this is in the end of this loop. What I have written is I am calling my agent function, and my query is what is the mass of the Earth plus the mass of the Saturn, and all of that times 2. Okay, so what it will do? First, it will calculate the mass of Earth, then it will calculate the mass of Saturn, and then it will multiply it by 2. So this is how in my first loop, what it will do? It will generate the thought. I need to find the mass of Earth and Saturn. Second is action. Get planet mass. It will send the Earth as an argument. Pause inside the loop. So I have just written some, we were testing it yesterday. So it will go inside the loop and it will find the name of the action and the parameter, and this is my observation. Once I pass it to the LLM again, my second thought is I need to find the mass of the Saturn. It will be sending the argument as Saturn this time. I will pass the name of the action and the argument. I will execute it. That function, I will call that function with this argument. I will get the result. I will set it as an observation. Will give it back to my LLM. It will say I need to add the masses of Earth and Saturn. So it will call the calculate. Okay, we will execute the calculate. I need to multiply it by 2, blah blah blah. I have the final answer. The mass of the Earth plus this is your first agent, guys. Okay, मजा आया नहीं आया?
So now this time it has come out of the loop after the 10 iterations automatically.
Yeah. It has got the answer, right? So we have defined if answer, then you have to break. You have to come out of the loop. Okay. If it is not able to find the answer and the 10 iterations are done, then also it will execute, because this calling these LLMs on this agents are actually very expensive, because you are sending lot of data. A lot of calls will go to the LLM, right? First it will do observations, and then it will do action, and the action will be invoked, and you are sending lot of data here and there. So if you don't want to pay that much, you want to control the cost, and to avoid infinite loop and costing, you can just put some iterations. Okay?
So we can use DeepSeek to reduce the cost expenses.
So these smaller models and all, which you can deploy on your local machine, they may not work well with the these agents basically. Okay. But if you are, I have not tried DeepSeek. I mean, does it provide APIs so that we can call it just like Grok? I think on Grok itself, is it there?
It's in the Grok, it's already deployed.
Okay, it's there. Okay, we can try DeepSeek. Okay. Yeah, I mean, we can try this. Instead of, so what you can do is, instead of trying this Llama 3.3, maybe you can replace it by DeepSeek. This also has a good context window, 128,000. Okay. Yeah, I mean, you can do that. You can see the performance. Okay, so this is all I planned today. I think you enjoyed this session, right? So the agent is something, which people struggle to understand. Even when I was trying to understand it, I went across maybe 10, 15, 20 videos. Then I was able to understand what is an agent is actually, what it is doing, and why it is helpful. Okay, in the next class, what we will do is we will deep dive into the frameworks like LangGraph, how we can automate all these things, how we can use LangGraph to create different nodes, their inputs, their outputs, and all those things, how it checks the different conditions, what it has to do. That will be, I mean, that is something which people use in the industry. In my last project also, I worked on agent. So I will explain you a little bit about that also. How we used agents. We had multiple nodes. In first node, I was calling LLM, right? And I created the LangChain where, because we had some documents, we vectorized our documents. We used RAG. So in agent also, what I created the first node where I had access to these RAG documents. So I created one chain. I executed that chain. I got the result out of my private documents. And then I was in the second node, I defined my own method, which will check whether the result has been generated is correct or not. In the third node, I was again calling LLM for checking something. So like that, you can build those complex workflows by joining all those things. You can define your conditions. You can define the format of the output and all those things. But yeah, for today, I think you must have got the concept of agent and how we can build agent just using Python without using any framework. Okay. Yeah. Any questions, guys? I think we can close early today.
Maybe like Surendra, can you please go back to the Grok, the models window here? Can you please explain to interpret these models? Maybe like here, like what is that context window and what is that max completion? And here, like, yeah, please.
Okay. So these are the production models. This is the model ID. Okay,
Mhm.
for example, this is Distill, Whisper, large model. This is Gemma from the Google. So they are different models. Everyone is having different number of parameters. For example, 70 billion parameter. Larger the model, better it is. Okay, so it has 70 billion parameter model, and this is just 8 billion parameter. This 8 billion you can download on your machine as well. Up to 8 million, you can 8 billion you can download the models and you can use them locally also.
Okay.
Okay, on your 16 GB RAM. So these are the name of different models. If you are going to use models for agent, don't use 8 billion or something like that. You try to use bigger models. Okay, like 70 billion or like that. So this is the name of the model. Who is the developer? The Hugging Face. So they have taken this model from the Hugging Face. They have taken Gemma from the Google. All these are open source models. They have taken these from the Meta. Okay, the second row is the provider. Mistral also has their model. If you don't specify any model in the Grok, then it will by default use Mistral. Okay. Next is the context window. Context window means when you are passing your instructions, your system prompt and your user prompt. So what we were doing here, we were sending this list of messages, right? So when you are
Yes.
sending those messages, then you have some cap, some upper cap. For example, if you're using Gemma, then you can only send 8,000 tokens in one request. Okay.
Okay.
So if I add my system prompt and the user prompt and everything, then the total number of tokens which I can send in one request is up to 8,192. For example, I was doing one project there. What we were doing is we were processing invoices. So the client had the requirement that whatever metadata or whatever details which are there in the invoice, for example, your invoice number, your PO number, your customer number, date, currency, you have to pull all those informations and you have to create a JSON out of it. Okay. For that, we were using GPT 3.5 Turbo, which is also having 8,000 as a limit. So now, when I defined my system prompt, there I had to tell to my system prompt that the currency can be in the dollars, currency can be in the pounds, right? You have to give some few short examples, right? So that it can catch when it OCR your or reads your invoice PDF, it should know, this is the customer number, this is my invoice number. So usko we have to give some examples that invoice date will be in these possible formats. Currency can be of these different types, because different invoices may have currency. Someone may put currency in left hand side, someone may put in the right hand side. So in order to explain LLM that these are the possible ways, few short examples we have to give them in the prompt itself. So we had total fields of 40-50 fields in the invoice. So if you give 3 examples for each field, they are like 150 examples. So the number of tokens was actually exceeding 8,000. So in such request, what we need to do is we need to use some other approach, or maybe you need to use some different models, some models which can allow even larger context window, but they are costly, right? 3.5 Turbo is the cheapest model. So that's a trade-off you have to do, right? So this is the number of tokens, and this is maximum completion tokens. Completion means your output. If this model cannot give you more than 32,000 tokens as an output,
In
as a
one
response
request.
in one
In one
request.
in one
Yeah,
request.
yeah.
Okay, okay. So here 70B means like the 70 billion parameters means like
Parameters.
it includes only in the input or throughout like
No.
this.
This 70 billion is something else. It has nothing to do with your context window input output tokens. This is the number of parameters in your neural network.
In a neural network. Okay.
When this model was trained, it was having 70 billion parameters. I have
Okay,
shown you,
okay.
right? In the
Yeah.
neural network, we have input layer, output layer, some hidden layers, and each
Hidden
hidden layer is
layers.
having some neurons which
Hmm.
has some weights and all those. So these are the number of those weights, number of those parameters. More number of parameters means it has more memory. It can understand and the more complex patterns and behaviors, images, videos, and audios. Okay? It has nothing to do with this means this is larger model. 8B is a smaller model. It has less number of parameters. Okay? What is maximum file size? This is, I think, these allow maybe to browse and send the file also. So this is the limit of file which you can send in one request. Okay, for example, Whisper models are the models which basically convert from your audio to text. Okay, so the file which you are going to send to this model, that should not exceed the size of 25 MB. And these cards are, again, if you click on any of these card, they will have further details of this model, how it performed, okay, how it behaves, what are the different variants. For example, Llama 3.1 comes 8 billion parameter model, 70 billion variant, and 405 billion. What are its characteristics? Model card means it's a card which will have all the information, how it is being trained, how was its performance against different benchmarks. So when a model is released, it is tested against some standard benchmarks, some coding problems, some translation problems, some math problems, some 10th level math, some PhD level math, to judge how this model is behaving, so that you can compare it with other models, right? If you want to compare different models, you have to test it against some standard data, and then you have
Yes.
to score how many of those questions it was able to do correctly. Then only you can judge, okay, this model is 85% accurate, the DeepSeek is 94, like that. ठीक है, तो इसमें वो सारी informations है. See, these are those benchmarks which I am saying. MMLU Pro, COT means your chain of thoughts, common sense question answer में कितना score है इसका, अलग अलग है ना. So you can decide which model you have to use. Okay. Reading comprehension, general knowledge कैसी है इसकी. So these are the different benchmarks against which these models are tested, and this is their score. This is how much they scored in this. ठीक है. Anything else, guys? Use all these things. I will share this Google Colab file practice. ठीक है. Any other question from anyone, guys? Sridhar, Jagdish, Jayant, Nivas, Ravi. Yeah.
So usually, like I'm from the Java background, right?
Mhm.
So whatever the code we wrote, right, and we will make it as an executable jar, and we will feed it to the web application where we have the supported libraries and all that stuff.
Mhm.
Coming to this kind of logic, right? How can
Mhm.
we map this logic with the web application like chatbot or something like that? That will
Yeah,
be
right.
covered.
Yeah, I mean, I will cover that in the final session.
Okay,
Okay.
that's
How to deploy these, how to package. I mean, I got your question
Mm.
because I'm also from the Java background.
Yeah.
So we
Okay.
used to create jar files, var
Yes.
files,
Yes.
EAR files, and we used to go to our application servers, deploy them,
Mm,
all the dependencies and all those stuffs. Okay.
Yeah.
Now
Okay.
the things have changed a lot. I will explain you how it can
Sure.
be done in the world of Python.
Okay. Okay. So my question, one more question is like we have like advanced topics in uh, like vectors and vector array, right? These kind of topics we will call it in numpys and all the stuff in Python, right? So that should be covered by ourselves, right? And you are not covering it, right?
Yeah. I mean, I will not cover because that is a part of the Python, but you need not to do all those things, right? We have developed a couple of applications, right? But
Yeah.
do you feel we actually we don't require them? But yes, if you have the understanding of how this NumPy is numerical Python, basically how to do these vector multiplications, matrix multiplications, and all those things. So I mean, if you have idea, that is fine, but that is not something which is very much mandatory.
Okay. Okay. Why? Because like I got the JD from other person, so
Mhm.
in the they kept these all topics. So
Mhm.
before giving a shot, right? I want to check with you.
Yeah. I mean, you can take any course from, some basic Python course. I think that should
Okay.
be.
Okay. Okay. Fine.
Yeah, NumPy. We have pandas. Pandas basically is used to create data frames, right? Whenever we are working on machine learning, first of all, we need to take our data which is there in the CSV or Excel files into some data frame. So that data
Yes.
frame is Panda will help you to read underscore CSV, and then we give the name of the CSV file. It will pull all the data and it will create some virtual table. and then you can, drop some columns, add some columns, and merge some columns, do some comparisons, where
Hmm.
clause, those operations are done with the help of those pandas library.
Okay. And coming to the comparison with the language, right, with respect of Python and Java framework.
Mhm.
So Python is like very easy to write and less lines of code
Correct.
compared to Java. And and both are robust, but coming to the performance, right, we should consider Java or Python.
I mean, the performance of Python is, I mean, if you're doing anything with the data or machine learning or data science, then Python is the only option, right? So I also remember the days when we used to create some jobs or, some kind of
Cron
files
job.
with the cron jobs and all those things.
Hmm.
Then Java used to create those files, like it used to take some time, right? You can actually see the processes going on.
Yes.
Yesterday I created some 2 lakh of rows, some test data I was creating with the Python. So with the help of ChatGPT, I wrote some code. So I had to create 2 lakh rows of 37 columns. So when I executed that Python code, uh, in 2 seconds, it generated that file actually.
Okay.
So there is a huge difference in the performance between Java and
Hmm.
this Python, because Python is more related to the data, and how to do all these things, creations and columns and comparisons and all these things, metrics. See, when you are training the models or you are dealing with the language models or any other model, you have to do lot of multiplication, right? You have to calculate the loss of your function, and then you go back and change your model's weights, right? You differentiate your result with the respect to the W1, W2, W3, you second level differentiation, third level differentiation, you put it to equal to 0. There are a lot of mathematics which goes on, and Python is a language which is being created having do all those things in the mind. How to make these calculations very quickly, how to do matrix multiplications, multi-dimensional multiplications, and all those steps.
Okay.
So
Okay.
yeah, I think Python is the way to go. Everyone should
Okay.
learn,
Hmm.
even if they are not going through this course, or because this is one of the famous. Even my kid, he is in 6th class. He has a Python, so you
Okay.
can think
Yes.
where the world is going. And he also has this subject in the computer. There is one chapter which is talking about artificial neural networks. I saw that neurons and input layers and output layers. I was surprised to see in 6th class they are teaching what is ANI, artificial neural intelligence. One is like ASI, artificial super intelligence, AGI, artificial general intelligence. Manka, these things even the people in the industry don't know sometimes, and they are teaching in 6th class.
So in that I remember like when I was in school, when we used to go to this computer labs, right?
Mhm.
They asked us to remove the shoes and come. Virus will come. Remove your shoes and come inside. You remember those
Ex-
days? They used to
ex-
say like in that way only, right?
Mhm.
Remove your shoes and come in the lab.
So
Because they
my
will say like virus will come or something will
mm,
happen.
mhm. So my school
So
had no computer. I mean, I don't remember we had any computer class up to school.
no,
In
no in
college,
KVs and all we used to have like
no. I mean, I am also KV pass out,
uh,
so we had
okay.
no computer lab.
So one class will be there. I believe
Mm-hmm.
in eighth, ninth standard or standard. So they used to say, okay, remove your shoes and come.
Mm. Yeah, I mean, those were the days, and now people are talking about humanoids, the robots looking like human beings. They have feelings, and I mean, they are listening. I mean, I saw one video where there was a humanoid, the human looking like robot, and it was listening to the conversations of the जैसे 3-4 आदमी खड़े होके बात नहीं करते हैं. It was standing with couple of peoples, and that robot was listening their conversations, and she was replying also. So just like human beings. So that level of automation has been this Gen AI and the race which is going on, right, for the last 3-4. This is really a big revolution, right? Just like we had earlier revolutions when the internet came for the first time, this is also one digital transformation which is going on. Anyway, yeah, guys. So this is all for today. Any other question before we close? Srivalli, you are always silent. Chalo, ठीक है. Okay, guys, enjoy rest of your weekends. If you don't have any questions,
Okay, happy weekend.
Yeah,
you
thank
too.
you.
Thanks everyone. Bye bye.
Bye.